Oh, okay. All right.
Did I do it?
That's fine, yeah. You're talking right in the microphone there. Any messages for fifth period? Oh, no, you're going to be all shy and embarrassed.
She's making fun of me.
Oh. Okay, all right. Number 21. This is a tricky one because there's a little bit of missing information here, but we can start with the stuff that we learned yesterday. It says, on Earth with a gravitational acceleration g, the potential energy stored in an object varies directly with its mass m and vertical height h. So that would mean PE, potential energy, varies directly, right? So that means we're going to have some constant k, and it says with its mass m and its height h. So that's what the general formula looks like. That's the formula you should be able to pull out of your brain when you read the sentence, varies directly with its mass m and its vertical height h. How do you feel about that?
I put GMH because I went back to
Right. Now we're going to plug in some stuff, okay? So the first thing that we're going to plug in is Jacob said he put G instead of K because gravitational acceleration is the constant in this case. Okay, so it replaced the G or the K with the G. All right. Then we can also replace the mass with 2 because we know that the skateboard has a mass of 2 kilograms. We don't know the height of the ramp, so we're going to leave that as H. So far, so good? Okay. Then if you look back to a previous example in the section, what is G? Anybody know? 9.8. So I'm going to replace the G with the 9.8. Nope, they didn't. So it's a good thing you guys asked for help on this one. So if I multiply that by 2, you get 19.6H.
If we didn't have to do that, why is that a good thing?
What's that?
If we didn't have to do that, why is it a good thing?
If you didn't have to do it? No, you had to do it.
No, we had to just write the equation.
Yeah.
We didn't have to do
But it's cool on it.
Yeah, because the answer in the back.
Oh, what did they start or stop? Oh, they did this right here. They didn't substitute in their gravity.
Yeah, you went hard.
Okay, all right. Sorry, went the extra mile. Okay, so either one of those is acceptable, I guess. But you should know that gravity is 9.8.
Yeah, I guess. I mean,
Because that's sort of a common knowledge.
It's 9.8 what?
9.8 meters per second. It's actually an acceleration.
I bet you could ask anybody, almost any student besides like in an advanced class, and they wouldn't hear.
Okay, next one, number 27. Once again, when you read that per sentence, there is an equation that should jump out of your head. Z varies jointly with X and Y, inspires you to write Z equals KXY. Okay? What do you do from there?
Plug it in.
Plug what in?
Or for X.
No, that's the final answer.
You find Z, right?
Right, we gotta find, no, we know Z, we have to find K. Alright? So we're, so I'm gonna plug in these values for Z and for X and for Y and use them to find K. So Z is 60, K we're trying to find, X is 2, and Y is 3. So what's K? 10. Alright, so now that you know K is 10, you can rewrite this as Z equals 10 times X times Y. And then now we can answer the question because it says find Z when X is 4 and Y is 9. What's that?
360. 360.
360. Did you get 360?
Yeah.
Okay.
I multiplied 3 times 2 is equal to 4. And 3 times
You multiplied the what?
I took the 2 and multiplied that by 2.
To get 4.
Yeah,
Okay.
I multiplied 2 by 3.
To get, okay.
And I took the 2 and multiplied those together because that's what I multiplied by. And I multiplied that by 6. I got 360.
Well, I'm not liking that very much.
Wait, so-
Well, I was okay with you until you said that last part where you said you multiplied these two together because that's what you
No,
multiplied.
I didn't multiply those 2. I multiplied the coefficient.
Oh, okay. And then you multiplied that by 6 and got, yeah, I'm okay with that. But that's the fact that this is
That's
a,
way easier.
the fact that this is a 2 and this is a 3, and then you multiply by 2 and you multiply by 3, that's just a coincidence. Okay. Other than that, I'm okay with my thing.
You can multiply by
Yeah, that'll work.
That's way easier.
All right, what else you wanted, what? 36, you said?
No, it wasn't that one.
Yeah, I like 36.
36? Okay, if it's an inch, if it's an inverse variation, what's true about the product of x and y? It's going to equal the same every time, and that same thing is the constant of variation. So if I want to find the constant of variation for those 2 points right there, I have to multiply those two things together. What's the square root of 2 times the square root of 18? Square root of 36, which is 6. So your constant of variation in that case is 6. All right? Okay, pass those forward, please. I know you really wanted to do this yesterday, and I told you you had to wait till today, but now you can get excited about it. So today we're going to learn how to graph these functions. I know that graphing is not your favorite thing, but I just feel like it should be because this is so easy, because it's all the same stuff as we've done all the way back to 8th grade when you were in algebra. No, it's important for you to understand the shapes of the graphs of different functions. That's a valuable tool that you're going to use when you are in future math classes, okay? All right, so this is what the parent function of a reciprocal function graph looks like, okay? You have one thing over here. This is called a branch of the function, and then you have another branch over here, okay? This particular graph is 1 over x, and you can tell that because this point right here is 1, 1, and this point right here is negative 1, negative 1. And since 1 divided by 1 is 1, and negative 1 divided by a negative 1 is also 1, that's the point that those graphs go through, okay? So we're going to take this general form, and we're going to do like we did before. We're going to stretch it, we're going to shrink it, we're going to shift it up, we're going to reflect it, we're going to move it left and right, and all that fun stuff, all right? Now, there might be a couple of things that you notice that are different about this function than other ones that we have studied. What is one of those things? There's what? Right, there's two separate pieces to the graph that are not connected, all right? And so what that means is that this graph is actually never going to cross the x-axis, and it's never going to cross the y-axis. Those two lines have special names. Those are called, anyone?
Wait, what?
You just
These
said
things right here.
branches.
X and Y.
No, the purple lines that the graph will never cross.
Line of
symmetry. Those are called asymptotes.
Oh, yeah.
What if it's 0?
Okay. What if what?
What if it's 0?
What if what 0? If x equals 0. Okay, so Tony is saying what if x equals 0? Then for this one right here, I would want to go 1 over 0. What's 1 over 0? Undefined. Yeah. So that's not going to work. Okay. So you can't plug in 0. James?
Will we ever have two lines like that in one quadrant?
Ooh, nice question. Yes, but not in this class. Okay, that can happen. If you go 1 over x squared, then that's what causes that to happen, but we're not gonna, well, maybe we will later in the section.
It's not right that train.
Okay, so yeah, that's a possibility. Okay, so that will be fun. All right, and then what we're going to do, like I said, is we're going to do the same stuff with the transformations, the stretches, shrinks, reflections, and translations of that. Okay. All right, so let's take a look. What is the graph of y equals 8 over x? Tony, this is for you. It specifically says x cannot equal 0. Okay, so good question before. What is that going to look like? And we're going to identify the x and y intercepts and the asymptotes and the domain and the range. So we got all kinds of fun stuff going on here. All right. So let's tackle this the way you tackle a normal graphing problem. Give me.
What is that?
he said, let's do that. Give me a value for x to plug into the equation. It specifically says, Luke, x can't be 0. That's the only number you can't pick.
8.
And you went right there. 1? Okay, when x is 1, what's y? 8. Because this is, okay, so when x equals 1, we just chose that randomly, y equals 8. So I'm going to put a point at x equals 1, 1, 2, 3, 4, 5, 6, 7, 8.
-1.
Okay, nice, that's better than 0. When x equals -1, what does y equal? -8. And so you can see where the other branch of the function is going to be over here. 1, 2, 3, 4, 5, 6, 7, 8. Let's go back and let's look at the parent function and let's notice some of the symmetry of this graph. If we have this point 1, 8 up here, where is there going to be another point down here somewhere? Yeah.
8, 1.
Yes, we'll do that in a second. Yeah. What'd you say?
8, 1.
8, 1. Good. If I choose that x equals 8, 8 divided by 8 is 1, so that's going to give us 1, 2, 3, 4, 5, 6, 7, 8, 1. Okay. What if I choose x is -8? What am I going to get? I'm going to get -1. 1, 2, 3, 4, 5, 6, 7, 8, right there. Okay. So let's grab the point right in the middle there. What's an easy one? What? 4, because 8 divided by 4 is 2. So if I plug in x equals 4, 1, 2, 3, 4, I'm going to get y equals 2. And then also if I plug in x equals -4, I'm going to get -2. Okay. How about if I plug in 2 is another good easy one. 2 gives me 4, and -2 would give me -4. What's true about all those points? What do they multiply together to equal always?
8.
8. Okay.
So it's a
1 times 8 is 8. 2 times 4 is 8. 4 times 2 is 8. 8 times 1 is 8. Okay, so that's what we were working on yesterday. Yes?
Pick the point that would go in the second quadrant.
It never will though, because if I choose a negative x value, when I divide a positive number by that, I'm going to get a negative y
So
value.
it's always going to be.
In this case, it'll always be. Now, Jake asked the same thing. There is a way that we can flip this to get it into that quadrant. We'll do that next. Exactly. Did you hear that? If this is a -8 on top, then if we take and divide by a negative number, we'll get a positive number, so we'll be up here.
So they don't always have to be diagonal from each other.
They do always have to be diagonal from each other, because if we do -8 and I plug in a positive x, then I'm going to get a negative answer, so I'm going to be down here.
So when you're doing the problem, every time it should be diagonal from each other.
Yep.
And if it's not, you're doing it wrong.
Exactly. Did you guys just hear what James said? Good little hint. Hey! Did you hear what he said? What did he say? Liar. Did you hear what he said? When you're doing the graphs, they should always be in diagonal quadrants from each other.
The graphs,
Okay? The graphs.
the graphs.
Did you
The
say
graphs. Yes.
Where did you get those 2 points?
These right here.
Yep.
I recognized that -4 went into 8 evenly, so I chose -4. I got -2.
Oh.
Oh,
it's more
okay.
in
Yes.
assumption. So
What I don't understand is like what makes it have to have two equations.
What makes it have to
Instead
have
of just
2
one
lines
line.
is this x can't equal 0 thing.
Oh,
Normally it would be connected, right? But as soon as you try and plug in 0, then you get an error, so there's a break in the graph there. for that.
So right is it, so the only time we do this is if it says x can't equal 0.
Right, but you should know that from looking at the function, that you can't plug in 0 there, because if you divide by 0, it's undefined.
So only if there's a.
If there's an x on the bottom, yeah, that's what you're looking for. Okay, and then if you just connect the dots, then you can see that the shape of that graph looks a lot like the parent function on the previous slide. You might say that it's been stretched by a factor of 8. Okay, yeah.
Your graph is silly because at 3, it should be 3, it should be like 2.333.
You're right. You're right. Okay. So since this isn't Mr. Helvey's class anymore, you can just sketch the graph like that. Okay. But if you want to be, did you see what Luke said? He wants to be super fancy and go 8 divided by 3, and that's actually 2 point something. So you're right. I made the shape a little bit wrong. But I'm good with, as long as you get the whole numbers right, then you can just improvise in between, okay? All right, so let's identify the x and the y-intercepts. What are the x and the y-intercepts?
No, there is none.
None. Tricked you. Never crosses the x-axis, never crosses the
I
y-axis.
wrote that in my
Okay.
notes.
All right, good job. And then the asymptotes. I know that's a funny word. The asymptotes would be right there up on the x-axis and right there on the y-axis. Yeah. Yeah.
Always gonna be like that?
No, because we're going to shift it around a little bit, so that's going to change it.
I don't.
Okay, let's do it right now, whether you want to or not. Okay, we got that. We did that already. All right, like I said, each part of the graph is going to be called a branch. And then this is pointing out exactly what James just said. If you're looking at a regular one, it's going to be in quadrants 1 and 3. If we do a reflection by throwing a negative in there, then it's going to be in quadrants 2 and 4, but it's always going to be kitty corner from each other, diagonal from each other. Okay, so that's good to know. All right, let's not graph all of these. Let's just do the easy part. So if we change from having y equals 1 over x to y equals 6 over x, with a is 6, what will that do to the graph? Well, now it's going to flip it.
Stretch it.
Stretch of 6.
Yeah.
So it doesn't matter if it's y on the bottom or x on the bottom?
It'll always be x on the bottom. What about if it was 0.25 over x? What would that do? It's compression of 0.25 because it's less than 1. Yep, so it's going to shrink it down. Okay, and then here's what you're looking for, yes. If I change it and make it a equals -6, then there's going to be two things going on. What does the negative do?
Flip over the x.
Good, flip over the x-axis. And then stretch of 6, yeah. Okay? So that's, like I said, that's something that we've done a lot before with a lot of different shapes of graphs, okay? All right, so let's do some other fun things with these graphs. So this was, we just did the easy part, this very first one. If the thing is greater than 1, it's going to be a stretch. If it's less than 1, it's going to be a shrink. And if it's negative, it's going to reflect it. But we can, you probably should, yeah, since it says take note specifically.
It does?
That's a clue. Maybe write it down. Yes.
The absolute value of the real, is that actually absolute value?
That is absolute value, yeah. Because technically, this number here, you would say is actually less than 1. So you might think, oh, it's less than 1, so it's going to be a shrink. But we're ignoring the negative and just saying 6 is bigger than 1, so it's a stretch. So you don't have to worry about that absolute value thing.
Why?
Yeah.
What kind of situation would that
Good.
be?
Yeah, don't worry about
Absolute value that A and C should be the same answer.
Yeah, don't worry about it. Don't get hung up on that, okay?
So don't forget your notes.
Yeah, yeah, you can just write if A is greater than 1, it's a stretch. If A is less than 1, it's a shrink. Okay, and then we can also translate. And this minus h down here, that's, you need to think of that as being the equivalent of inside the parentheses. So that's going to move it to the left or to the right in the opposite direction. And then the plus on the end is going to move it up or move it down, okay? So like I said at the beginning, this is real similar to stuff that we've done with a lot of different types of graphs. So this should not be too big of a stretch on your mental faculties. Okay? All right, so let's try one that's a little bit trickier. I expect you to write it down in less than 15 seconds.
That's tricky.
I guess both of our expectations are going to be disappointed, aren't they? All right, so here's how you do these graphs. And this is really going to bother Luke a lot because we're going to be sloppy. Okay? Normally, in the parent function, the asymptotes are the x and the y axis, right? Okay? This plus 1 is going to do what to the graph?
Left.
It's going to move it to the left 1, and so that means I need to take this asymptote here and, oh,
Got it.
now it got connected to the top for some reason. So I need to take that asymptote there and move it to the left 1. Okay? What does the minus 2 do?
Bring it down to.
Brings it down 2. Okay? Here is all I need from you for you to get the understanding that I'm looking for. And Luke, just cover your ears. Is this graph going to be in the first and the third, or the second and the fourth? First and third, why? Right, because this is positive. So once you have those asymptotes drawn in there, here's my graph.
Wait, really?
Yeah.
Yeah.
Okay? Just draw that same shape snuggled up against these new asymptotes. Okay? Yes?
It's always going to run alongside the asymptote.
Yeah, that's what an asymptote means. It's where this graph is going to get closer and closer to this line without ever touching it.
But it'll never make a circle.
No, It's
So,
just going to keep on going this way forever and ever and ever and ever and ever and ever and
It'd
ever.
be cooler for the circle.
Okay?
So that
Yeah.
actually. So the x plus 1 just makes it go left 1.
The x plus 1 makes it go left 1, and the minus 2 makes it go down 2. Okay? Easy peasy, yes.
How can it never touch it though?
Weird, huh?
Yeah, because it keeps going closer. and
Okay, so
closer.
let's deal with a simple one that we were graphing before and use that to answer the question. So if I look at the graph of y equals 8 over x, what you're saying is you feel like this graph eventually should touch the x-axis?
If it's getting closer and closer.
If it's getting closer and closer? Okay, give me a huge number.
800,000.
Right, okay, so if I say x is 800,000,
Yeah.
does y, what does y equal?
100,000.
8 over 800,000, which is 1 over 100,000, okay?
1e to the negative.
So I
x.
would go all the way out to 800,000 in the x, and then my y value is going to be just barely above the x-axis. Is this 0?
Okay, so it'll always have 1 on the top.
Right. See how that happens?
Yeah, so
So
basically
even if we chose 800 million, okay, it's still going to be 1 over a million, so it's going to be just barely
Not
above.
getting
What
closer.
about what?
It's getting closer,
Billion.
How can it get closer?
because if I choose 800 million,
Try 800 billion. Get infinitely close.
right, it can get as close as you want. It can get infinitely close to this line, but it'll never touch it, because if I choose 800 million, then my y value would be 1 over 100 million, okay, which is closer to the x-axis than this, but still not touching.
Try 1 trillion.
Okay, don't want to. Jake?
So that's pretty much like what we were talking about the other day, like how some decimals can go on forever, but they're not infinity.
Right, exactly. Yeah, okay? So I know that's kind of a, but that's what's happening. Okay? You can get as close as you want, but it will never ever touch. Right, but you never get a touchdown. Does that make sense? So in football, if you get a penalty and you're inside the 10-yard line, then you go half the distance to the goal.
We're talking to someone that doesn't want.
Oh, you're not a football guy. All right, never mind.
Yeah,
But you'll
so
never get a touchdown
that
off the
works.
penalty.
That
Right.
doesn't work.
Right. Okay, so do you guys understand what I did here with this graph? Just drew in where the asymptotes were and then just put the
I
thing.
understand now.
You can't ball when everybody's in the
Right. If you're putting in golf and you keep hitting it halfway to the
He
hole.
said why, I like McGuire.
Oh, okay, yeah, there you go. All right, so let's do the same thing with this one.
Except I shoot fast.
Let's do the same thing with this one. What will the x minus 4 do?
Right for.
Move it to the right 4. So 1, 2, 3, 4. And what will the plus 6 on the end do?
I'm not gonna go.
Move it up 6. 1, 2, 3, 4, 5, 6. Is there a negative in the house?
Oh,
Nope, so that means that it's going to be in this quadrant right here and in this quadrant right here. Okay? I mean, is there negative in the problem? Is this, what I should have said, is that negative? If that's negative, then it would flip it. Okay? But it's not, so it doesn't. Okay? All right, let's go the other way around. How far to the left or right has this graph been shifted? And notice the scale, we're going by 2s. We're going by 2s.
2, 3.
It's been 3 to the left, right? So that means it's going to be x plus 3. How much did it go up?
4.
Up 4. So that means it is choice A. And the only way I knew to put a 2 on top there is because all of these options had a 2 on top already. Okay? So this would be the equation of this graph, yes. This 2 right here. Well, if you look at it, then there's a stretch of 2, but it's a multiple choice, so I knew there was a 2 on top. Okay? All right? Okay, what is the graph of this? So it's going to give you that number right there. Okay? So they're saying this is a translation of 2 over x. What is the equation for this function? So how far to the left or the right did it go?
1.
To the right, 1. So that would be 2 over x minus 1. How far up or down? Down 4. So then I would tack a minus 4 on the end. Okay? Pretty simple?
No.
So you can take the equation, you can make the graph, you can take the graph, and you can make the equation. We can skip with the word problems
That's
and
it,
get
right?
to the assignment.
No word problem? All of them?
I don't know, I haven't looked at it, but yeah, I'm guessing there's some graphs to be sketched in there.